Hello everyone. Today I would like to talk about multiple choice questions, MCQ, step-by-step guide to problem solving. So first topic I'm going to discuss today is acids and bases. Let's move on to questions. The first question is, which of the following is a Lewis acid? There are four answers given. Lewis acid and the Lewis base. Lewis acid is chemical species that can be accept a pair of electron from a Lewis base. For example, for the Lewis acids BF3, K+, magnesium plus or any other cation, carbon dioxide, aluminum chloride, AlCl3, they can accept a pair of electrons to make another bond. What are the Lewis bases? Lewis bases means chemical species that can donate a pair of non-bonding electrons. Non-bonding electrons, another name is lone pair electrons. For example, OH minus. OH minus ion can donate lone pair of electrons to incoming H plus ion, make H2O. NH3 can donate lone pair of electrons on nitrogen to incoming H plus ion to make NH4 plus ammonium ion. The same way OH minus, H2O, fluoride or any kind of anion can act as Lewis base. Question number 2. What is the pH of 0.001 molar HCl solution? HCl, hydrochloric acid. It is a strong acid. Strong acids dissociates into ions 100%. They completely ionized into H plus ion and chloride Cl minus ions. Then H plus ion concentration is same like HCl concentration. pH is equal minus log H plus concentration. Minus log 0.001, then pH is equal 3. Before you apply the concentration in the calculator, you can use this simple format. 0.1 H plus ion concentration, negative log of 0.1 is pH 1, and if you take negative log of 0.01, it's pH 2, 0.001 pH 3, 0.301 pH 4, and so on. You can identify a pattern. Next question. Which of the following pairs of substances form a buffer solution? There are four answers given. What are the buffers? A buffer is a solution that resists changes in pH when small amounts of acid or base are added. Buffers are essential in many chemical and biological processes to maintain a stable pH environment. For example, maintaining our blood pH. Our blood pH maintained between 7.35 to 7.45 within the narrow pH range using a buffer present in our blood. Buffers are typically made from the weak acid and its conjugate base, or mixture of weak base and its conjugate acid. Examples for the buffer: acetic acid. Acetic acid is the weak acid, and when we combine with its conjugate base, sodium acetate, it acts as a buffer. Ammonia. Ammonia is the weak base in H3. Ammonia conjugate base is ammonium plus cation. When ammonium plus cation combine with Cl, it's ammonium chloride, conjugate acid salt. So if we combine this weak base and its conjugate acid salt, it is a mixture. Buffer can be weak acid and its conjugate base salt, or weak base and its conjugate acid salt. Next question. What is the Kb for ammonia NH3? If its Ka value for ammonium ion is 5.6 times 10 to the negative 10 at 25 degrees Celsius. So here Ka, acid dissociation constant. Kb we called base dissociation constant. What is the connection between Ka and Kb? Ka times Kb is equal Kw ion product constant. Ion product constant Kw value is 1.0 times 10 to the negative 14 at 25 degrees Celsius. If we divide both sides by Ka, you can get this equation Kb is equal Kw divided by Ka. Now let's apply the values. Kw is 1.0 times 10 to the negative 14 at 25 degrees Celsius divided by Ka is given in the question 5.6 times 10 to the negative 10. Then Kb is equal 1.8 times 10 to the negative 5. Next question. Which of the following solution has the highest pH? What are the pH ranges? pH scale driven from 1 to 14. pH is equal 7. The solution is neutral. pH is less than 7. Acidic solution. pH is greater than 7. Solution is basic. Now the question asks about highest pH solution. Highest pH means the basic solution. pH values above 7. It should be a base. Let's go to the answers. HCl. HCl is hydrochloric acid. It is one of the strong acid. pH of the hydrochloric acid is less than 7. Sodium hydroxide. It is strong base. Sodium hydroxide strong base pH is above 7. Next, acetic acid. It is a weak acid. pH is greater than strong HCl. However, still acetic acid pH is in acidic range, less than 7. Ammonium chloride. Ammonia NH3 is a weak base. pH is around 11. But ammonium chloride is acidic chloride. It is derived from weak base ammonia and HCl strong acid. So the salt is acidic. pH is less than 7. Only NaOH pH is above 7, the highest pH. Next question. During the titration of weak acid with strong base, the pH at the equivalence point is. There are three types of titrations. Strong acid versus strong base titration. Then the pH at EQ, equivalence point, is neutral. pH is at 7. The second type of titration, strong acid versus weak base titration. Then the equivalence point is at the acidic pH range. pH is less than 7. If we titrate weak acid against a strong base, pH at the equivalence point is light above 7 in the basic region. So the question asks about weak acid and the strong base, then the pH at equivalence point is closer to the stronger side, that is basic pH greater than 7. Next question. What is the pH of the buffer made from 0.1 molar acetic acid and 0.1 molar sodium acetate? This is acid and its conjugate base salt, sodium acetate and acetic acid. Ka value of the acetic acid given 1.8 times 10 to the negative 5. How we can calculate pH of a buffer solution? Using this equation. This is Henderson-Hasselbalch equation. pH of the buffer is equal pKa of the acid plus log conjugate base concentration divided by acid concentration. What is pKa? pKa is equal negative log Ka. So Ka value is given in the question. Let's calculate pKa first. pKa is equal negative log 1.8 times 10 to the negative 5. So after you solve this, the value is 4.74. Now let's apply the Henderson-Hasselbalch equation. pH is equal pKa 4.74 plus log conjugate base concentration 0.1 divided by acid concentration 0.1. So 0.1 cancel, the answer is 1. Log 1 is 0. Then pH is equal 4.74 plus 0. Same value. pH is equal 4.74 in this buffer solution. Next question. Which of the following indicators is the best suited for the titration of weak base with strong acid? First, we need to identify the weak base against strong acid. At what pH range valence point is lies? Weak base and strong acid titration. A suitable indicator for this type of titration is one that changes color in the acidic pH range. The common indicators for this titrations: methyl orange, pH range 3.1 to 4.4, bromophenol blue, pH range 3 to 4.6, methyl red, pH range 4.4 to 6.2. Among these given choices, methyl orange is the best answer. Next question. What is the concentration of H plus ions in a solution with pH of 4? So last time we discussed, if we know H plus ions, how we can calculate pH using negative log H plus ion concentration. But this is completely opposite. If we know a pH value, H3O plus concentration, or simply we can write H plus ion concentration is equal anti-log, and then we need to type negative pH value. Using the calculator, you can apply this anti-log function. You can press shift button and then log button. Or in some calculators, second plus log. Then it give anti-log function. Then type the negative of your pH value given, negative 4. H3O plus concentration here 1 times 10 to the negative 4 molar. Let's move on to question number 10. Which of the following compound is amphoteric? What is the meaning of amphoteric? Amphoteric substance is one that can act as both an acid and a base. In some chemical reactions, amphoteric substances donate protons, proton being H plus ions, acting as an acid. Or in some chemical reactions, they accept H plus ions or proton acting as a base. This is depending on the chemical environment. Examples for amphoteric substances. Water is a common example. In addition to water, aluminum hydroxide, bicarbonate and iron act as amphoteric substance. For example, bicarbonate minus. In some chemical reactions, bicarbonate can donate H plus ion to become carbonate and H plus. Then bicarbonate act as an acid. In other chemical reactions, bicarbonate can accept a proton to form H2CO3 carbonic acid. Then bicarbonate act as a base. Next question. Which of the following acids has the highest Ka value? Ka is acid dissociation constant. Stronger the acid, larger Ka values. Now let's check what are the given answers. Hydrofluoric acid, HF, it is a weak acid. Acetic acid, it is again weak acid. Hydrochloric acid is a strong acid. Carbonic acid again weak acid. Only strong acid given here, HCl, it has higher Ka values than the other 3 acids. You can see there are 7 strong acids. All the other common acids are weak acids. The strong acids are hydrochloric acid, HCl, hydrobromic acid, HBr, hydroiodic acid, HI, sulfuric acid, nitric acid, chloric acid, HClO3, and perchloric acid, HClO4. Next question. What is the pH of 0.01 molar sodium hydroxide solution? Sodium hydroxide is a strong base. Like strong acids, strong bases are strong electrolytes. They can dissociate into ions 100% completely. Then the OH minus ion concentration is same like the sodium hydroxide base concentration. So we can use this equation POH is equal negative log OH minus concentration. So POH is equal negative log OH minus is 0.01 then pOH is equal to. But the question asks about not pOH, we need to calculate pH. How we can calculate pH? pH plus pOH, if you add together, this is equal to pKW. pKW is 14. Then we can rearrange the equation. pH is equal 14 minus pOH, 14 minus 2, pH is equal 12. Next question. Which of the following is a diprotic acid? What is the meaning of protic? Protic means ionizable hydrogens. How many ionizable hydrogens? There are three types. Monoprotic acid, one ionizable hydrogen, one acidic hydrogen. Diprotic means two ionizable hydrogens and triprotic means three ionizable hydrogens. The examples given here. Monoprotic acids are common: hydrochloric, hydrobromic, hydroiodic. You can see all these acids, only one hydrogen can ionize or can donate. For example, acetic acid. Acetic acid, there are four hydrogens you can see. Three hydrogens connected to carbon and one hydrogen next to oxygen. But here, only hydrogen connected to oxygen is the ionizable or acidic hydrogen. The hydrogens connected to carbon, they are not acidic. So acetic acid is a monoprotic acid. Diprotic acids. Carbonic acid H2CO3, oxalic acid H2C2O4 and sulfuric H2SO4 are examples. They can donate two hydrogens. Triprotic acid, phosphoric acid H3PO4. So H3PO4 can donate one hydrogen at a time and there are three Ka values, three acid dissociations. Next question. Which of the following best describes the pH change when small amount of strong acid is added to buffer solution? We defined buffer in an earlier slide. Buffer is a solution that resists changes in pH or pH change only slightly when small amounts of the acid or the base is added. pH change slightly, answer D. Next question. What is the conjugate base of sulfuric acid? The concept here is acids are donate protons. According to Bronsted and Lowry acid-base definition, acids are proton or H plus ion donors. Bases are H plus ion or protons acceptors. So acid donate protons and the species remaining we called its conjugate base. So let's apply H2SO4 to this equation. Acid is H2SO4 and it donates H plus ion. What is the species should be here? It is HSO4 minus. HSO4 minus we call hydrogen sulfate or bisulfate. When hydrogen sulfate combined with H plus, you can see it can make H2SO4. Next question. A solution has a pH of 5. What is the concentration of OH minus ions in the solution? There are four answers given. First, let's see what is the connection between pH and the pOH. At 25 degrees Celsius, pOH and pH, if you add together, it is equal to pKW. So pKW value is 14. pOH plus pH 14. Then we can calculate pOH value because pH value is given, it's 5, 14 minus 5, pOH is 9. If you know pOH, how we can calculate OH minus concentration? OH minus concentration is same like we calculate before, anti-log, negative pOH value. So OH minus is anti-log, negative, the pOH value is 9, so negative 9. Then the answer is 1.0 times 10 to the negative 9 molar is the OH minus concentration in this solution. Next question. During the titration of strong acid versus strong base, what is the pH at the equivalence point? This is strong acid versus strong base. Both are strong. Then equivalence point pH is at the neutral pH, pH at 7. So the answer is pH equal to 7. Next question. Which of the following is the strongest acid? So last time we discussed what are the 7 strong acids. Among those list, HCl is one of the strong acid. HCl, HBr, HI, sulfuric, nitric, chloric and perchloric. All the other acids are weak. Carbonic acid, H2CO3 is a weak acid. Hydrofluoric acid is a weak acid. Ammonia, NH3 is a weak base. Let's move on to last two questions. Question number 19. Which of the following salts will form a basic solution when dissolved in water? This is salt's acidity and the basicity. There are three types of salts. The first one is salt derived from strong acid and the strong base. The reaction is acid plus base produce salt and water. When salt derived from acid, strong acid and the strong base, the pH of that salt is equal 7. Second type of salt is the salt derived from strong acid and a weak base. Then the pH of that salt is less than 7 acidic pH. Third type is a salt derived from weak acid and strong base. Then the pH of the salt is above 7, greater than 7 in the basic pH. Now let's move on to the given answers. First answer is ammonium chloride. Ammonium chloride salt made by ammonia weak base, NaCl strong acid. Then the pH of the ammonium chloride is at the acidic medium, less than 7. Second salt, sodium carbonate. Sodium carbonate is made by sodium hydroxide strong base and carbonic acid weak acid. Then the pH of the salt is closer to the stronger side, above 7. KCl. KCl salt is made by KOH strong base and HCl strong acid. Then the pH is equal 7. pH of the KCl solution is neutral. The last salt is sodium nitrate. Sodium nitrate salt is made by combining sodium hydroxide strong base and nitric acid strong acid. If both are strong, sodium nitrate salt pH is 7, neutral. Next question. What is the pH of 0.1 molar solution of acetic acid? Acetic acid Ka is given, it's 1.8 times 10 to the negative 5. Acetic acid, it is a weak acid. Weak acids are weak electrolytes. The meaning is only partially dissociate. Only small fraction of the acid dissociates into ions. The majority of the acid molecules remain as acetic acid molecules. So here we assume that only X amount dissociate. This is the equilibrium reaction, acetic acid, equilibrium with acetate anion, NH plus ion. So let's create ICE table. I is for initial, C is change, and E is equilibrium. At the beginning, 0.1 acetic acid solution present. So no acetate ions or H plus ions. But after some time, only few acetic acid molecules dissociate. We can assume only X amount dissociate. So minus X amount decrease from this solution, same amount of acetate and the same amount of H plus ions generate, plus X amount added. The reason is equation is balanced. So 1 mole of acetic acid dissociates into 1 mole of acetate and 1 mole of H plus. Molar ratio is 1 to 1. then X amount decrease from acetic acid means same X amount of acetate and H plus ion generate. Now what is the remaining at equilibrium? Initially 0.1, from 0.1 X amount decrease, remaining 0.1 minus X. Acetate and ion, initially 0 and then X amount added. So the remaining at equilibrium X amount. For H plus, initially 0, X amount added. So the remaining at equilibrium is X. Now we have concentrations of each species at equilibrium. Now let's go and find Ka expression. This is acid dissociation constant expression. All the products in the numerator, product concentrations divided by all the reactants in the denominator, reactant concentrations. Now let's apply the values from the ICE table. Acetate ion concentration X times H plus ion concentration X divided by at equilibrium acetic acid concentration 0.1 minus X. This is equal to Ka of the acid given in the question. When you are solving this equation, we may need quadratic equation. However, we are making assumptions for our convenience. But at the end, we can check the validity of this assumption. Here, I'm not going to prove that the validity of the assumption, but let's use the assumption first. I'm planning to explain how we can check this assumption validity in a future slide. So let's use this assumption. Assume 0.1 minus x is equal to 0.1. The meaning is if we consider the x amount, the amount dissociates from acid is very small, negligible compared to the 0.1. Only a small fraction dissociate. So 0.1 minus small number is closer to 0.1. That is the assumption. Then we can simplify the equation. Ka is equal x times x divided by 0.1. So after we solve this, our x value is 1.34 times 10 to the negative 3. This x value means H plus ion concentration. That is 1.34 times 10 to the negative 3. If we know H plus ion, we can calculate pH. pH is equal to negative log 1.34 times 10 to the negative 3. Then the answer is 2.87. Thank you all for watching. If you find this helpful, subscribe to the channel for more learning.